integral from 0 to 3 of that function. So how are we going to do it? Well, an integral is an antiderivative. So we're going to do antiderivative. So you add 1 to the power, and then you divide by that. Plus, and then the next one we're going to do antiderivative. So 7. Now what's antiderivative e to the x? He's our favorite derivative and antiderivative. He does nothing, right? And then we're going to evaluate this between the bounds, 0 and 3. Let's clean up that first part, though. That's just x to the fourth, right? We don't really, that 4 over 4 is just 1. So do this. We're evaluating between 0 and 3. So what does that mean? It means you take the 3 and plug it in, plug it in. So you get 3 to the fourth plus 7e to the 3 minus, and then you plug in the 0. Boom, boom. So you get 0 to the fourth plus 7e to the 0. So that's how we do the integral. Plug in the upper bound. We do the antiderivative and then plug in the upper bound first to both of them. Then plug in the lower bound and we put a minus between them, subtract them. So then, what does this become? 3 to the fourth, you can use Desmos if you need to. 81 plus 7e to the third. I'm just going to leave it like that. In fact, I don't really need these parentheses anymore. And then I'll let this minus distribute minus, that's just 0, minus 7. What is e to the 0? Anything to the 0 power is 1. So in the end here, it becomes 81 plus 7e to the third minus 7. All right? And 81 take away 7 was that 74 plus 7e to the third. I think that's our answer. Yep, 74 plus 7e to the third. There we go. Just do the antiderivative of both of them and then plug in the upper bound, plug in the lower bound, subtract them in between. Don't forget to distribute that minus sign. That's why we put the brackets, so we can remember to distribute the minus sign. So there we go.